Hello everybody and welcome back to Absolute Value. Algebra 2 moves fast and factoring is the number one skill that you'll need to survive the first month. So today we're going to break down 3 different tricks on factoring. So grab a piece of paper and let's work through a few essential readiness problems together. Starting with our first type here, which is called greatest common factor. This type of factoring is typically the type you would start with. Anytime you see a factoring problem, you should always try to do this first. This is your first line of defense, okay? And right now, I'm going to show you how to do it. We've seen this term greatest common factor before. Typically, when we've been talking about numbers, maybe even in elementary school, we've seen this, where if two numbers share a common factor, that means that the same number can evenly divide into both of the numbers we're talking about. So as just a simple example, if we're thinking of the number 12 and the number 14, both of these numbers, 2 can evenly go into both of them. So 2 is a factor for both of them. Greatest just means it's the greatest factor that they both have in common. So now we're just going to apply this to our algebra expressions by seeing what do each of these pieces have in common. So let's look at this example here. Here we have 3x squared plus 12x. What do each of these things have in common? A good way to look at it is, let's first look at the numbers. So we've got 3 and 12. What number can divide evenly into both 3 and 12? That's 3. What else do these two things have in common now that we've dealt with the numbers part? Well, they both have an x, so we can also take an x out. And remember, factoring is kind of reverse multiplying or the opposite of distributing. So here we're really saying if we were to multiply 3x by something, that would give us this original here. So what do we multiply by 3x to get 3x squared? That would be x. What do we multiply by 3x to get 12x? That would be plus 4. And this right here is your final answer. This is your fully factored form. So now that we've got the main concept down, let's try a few practice problems with this type. So for our first practice problem here, again, let's look at the numbers first. So 5 and 20. 5 and 20, what number can both go into 5 and 20? That is 5. And again, both of them have an x, so let's take an x. Now we can't take an x squared out, even though this first one has x squared, because the second one does not have a square there. There's only one x instead of two x's. So anyway, what do we multiply by 5x to get 5x squared? That'd be x. What do we multiply by 5x to get negative 20x? That's minus 4. And there's our final answer, our final factored expression. Let's try one more practice here. 2x cubed plus 14x squared. So numbers wise, the biggest number that goes both into 2 and 14 is 2. And the first part has 3 x's, while the second part has 2 x's. So we can take 2 x's out. We can take an x squared out. Now what do we multiply by 2x squared to get 2x to the third? X. And what do we multiply by 2x squared to get 14x squared? 7. And there's our factored expression. So that is our first type. That is the first method of factoring that you always want to try. Let's go on to the next type. The next type is called difference of two squares, and you'll see why in a second. Sometimes people shorten it as dots, difference of two squares. And what this means, this is referring to perfect squares, right? Like perfect squares are 1, 4, 9, x squared, something that you have multiplied by itself in order to get this number. So like 1 squared is 1, 2 squared is 4, 3 squared is 9, x squared is x squared. So we're talking about perfect squares, and we're talking about the difference. Difference, remember, in math language, difference means subtracting. So we're always going to see a subtraction sign between these two perfect squares. Okay, so as we can see here in this example, we've got two perfect squares. We've got x squared, which is just x squared, and we've got 49, which is 7 squared, and there's a subtraction sign between them. So we are looking at a difference of two squares, which means we can factor this nicely. The nice things about these ones is that we're going to end up with our two groups of parentheses here, and all we do is we take this x, put it at the beginning of each parenthesis, and the 7 will just go here and here. And the signs in the parentheses are just going to be one positive and one negative. Now we need that positive 7 and negative 7 because that cancels out our typical middle term that we find in quadratic expressions. And so that's it for difference of two squares. This is our fully factored form right here. Okay, so now let's try a few practice problems with that now that we've seen the example. So now we've got x squared minus 81. This is x squared. This is 9 squared. We're just going to set up our two parentheses, put an x and a 9 and a 9, a positive and a negative, and we're done. Let's try one more example here. 4x squared minus 25. This one's a little bit trickier. So what do we square in order to get 4x squared? Well, in order to get x squared, we square x, but in order to get a 4, we have to square 2. So the 2x is the thing being squared, and then over here, it's 5. Now let's just set up our two sets of parentheses, and we'll put our 2x, and our 5, and 5, and remember it's going to be a positive and a negative. And there it is. So now we've gone through two of the types. Let's talk about our third type, which is factoring trinomials. So a trinomial typically looks like something like this. Just look at our example here. We've got an x squared, we've got a middle term here with just a number and an x, and then we've got our constant at the end, which is just a number. It's always going to look like this, but when we're factoring these, we have a similar setup for like we did the previous ones where we have two sets of parentheses, but we need to figure out what two numbers add to get -5 and multiply to get -24. So in order to do this, let's make a little factor tree of all numbers that multiply to get -24. Now remember, since this is a negative number, it would have to be a positive and a negative that multiply in order to get a negative. So let's just go down through some numbers. We have 1 and -24, 2 and -12, 3 and -8, 4 and -6, and then all of the opposites. And now in this group, we're trying to find, these are all numbers that multiply to get -24. We need to find the pair of numbers that add to get -5. And it happens to be right here. 3 plus -8 is -5. So what do we do with those numbers? We just put them in here. We have a +3 and a -8. And then in order to get an x squared at the front, we'd have to do x times x. So that's how you factor a trinomial. Okay, so now let's just do a couple more practice problems with that. Next one, remember we need to find two numbers that add to get 7 and multiply to get 12. So multiply to get 12, we have 1 and 12, 2 and 6, 3 and 4. We found the one that adds up to 7, 3 and 4. So we're going to set up our two parentheses, and that means the factors are going to be x plus 3 and x plus 4. Last one here. Again, we know we want to add up to get -2, multiply to get -15. All the numbers that multiply to get -15 are these, and these right here add up to get -2. So we've got x plus 3 times x minus 5. And there's our final factored form. Now we're just going to do one more thing. We're going to do a bonus level, which is combining the methods. This is a typical question that you see in Algebra 1, sometimes on the final exam, on the Regents, they like to use that. You'll see this also in Algebra 2, where it says factor completely, and they give you this thing, and you don't know which method to use. Always start with Method 1, GCF. See if there's any common factors you can take out of here first, so that it makes it a lot easier for us. So a number that they both have in common is 3, so we can take 3 out. But since the 12 doesn't have any variables, that's the only thing we can take out. Then what's left inside is x squared minus 4. Oh, and look, we're not done. It says factor completely, and I know that thing in the parentheses, that is a dots. That is a difference of 2 squares. So we can break this down even further. That difference of 2 squares turns into x plus 2 and x minus 2. Now we are done. Now it is factored completely. And now you have remembered all the ways to factor. So this year coming up in Algebra 2, when the first month where they're talking about factoring and quadratics, this is going to be very useful to you, and hopefully my video helped. As always, feel free to leave any questions or comments in the comments section. Give us a like if you liked this video and if you found it helpful. Subscribe to the channel to see more videos like this. I'm going to keep going with stuff even over the summer to keep our brains warm and fresh for the next school year. Thanks again for watching, and I'll see you next time.